Hello everyone, this is Simple Math for You and we will continue Absolute Value Functions Part 2. أهلا بكم من جديد وسنكمل الجزء الثاني من القيمة المطلقة دوال القيمة المطلقة. In the previous part we studied the translation الإزاحة and the translation was the effect of adding or subtracting سواء inside the bracket or outside the bracket like this or the bracket, for example x something, a number here on or inside x or plus or minus the number was inside. This is called translation and that means it will move left or right. Here it will move left or right and here it will move up or down if it is outside. Also we studied, and the translation can be visualized here, by the way. We can check here this graphing software. This is the absolute value function. It's very clear that it has V shape. If you add any number outside, it will move up 2 units. But if you have to add, or if you need to add inside the bracket, it will move to the left or to the right, and it's very clear here. We also studied what we call the dilation. The dilation results from multiplication. Dilation اللي هو التكبير والتصغير, stretching or compression, and it is resulting of multiplying the absolute value by a number. It can be inside or outside. If it is outside, then it's vertically affecting compression or stretching, or inside horizontally affecting. And we can visualize that as well in the graphing software. This is the parent function, as you see, the V shape. And we can see that when you multiply by 4, the graph becomes thinner. It is vertically stretched. If you multiply it by 1/4, which is less than 1, it is vertically compressed, as if you are compressing from upward. Today, we will study the effect of the negative sign outside. Let's see if you put the negative outside the bracket, outside the absolute value, what will happen? As you see, the graph is reflected across the x-axis. And we studied that also in the linear function, انعكاس. الانعكاس نوعين, the reflection is 2 types. It can be reflected across the x-axis when the minus is outside, even if there is a factor, no worries. It can be reflection across y-axis, means if the absolute value over here, then this will deal as a mirror, so the result will be on the other side of the y-axis. It is affecting horizontally, as we get used to for any inside factor. While here, for the vertical, let's see how it looks like. If it was up, let's say somewhere here, the reflection will be across the x-axis. That means it will be over here. The mirror will be your x-axis. So the minus sign will not be considered as a part of the factor. It will just affect the reflection. يأثر على الانعكاس كأنه صورة مرآة. Now let's apply what we have learned here on the absolute value. Describe the reflection as it relates to the graph of the parent function. Now have a look here. We have a minus sign and it's outside the group. So there is reflection definitely. But since it's outside, then it is over or across the x-axis. Means the graph, instead of opening up, it will open down. It will be flipping. Now, what is the effect of 3? The effect of 3 is what we studied last time, the dilation. Since it's outside, and 3 more than 1, and multiplied by the absolute value, then it is stretched vertically by this factor, stretched vertically by 3. Let's see here. There is also minus sign, but now it is inside the group. So there is reflection, flipping, but this time it's across the y-axis. And the 3 as well will affect the same effect as the beginning. It is stretched vertically. Let's see here. We have negative inside, so reflection across x-axis. Sorry, across y-axis. As inside we said y-axis, yes, it's inside across y-axis. And we have 0.3 inside the grouped. So the effect is horizontal effect, as we said last part, horizontally. What? Since it's less than 1, it will be the opposite effect of the vertical thing. So it is horizontally stretched. Okay. So we will not consider the negative to compare to 1. We will compare the number itself, the absolute value of the number. The negative will affect directly reflection, so it will be upside down, or it can be reflected across the y-axis. انعكاس عبر الواي. Now let's summarize here in this example all what we have learned. We have here the minus sign, the reflection. It is outside the group, so it is across عبر x-axis. Now we have also the 3, so it is stretched vertically. What else? We have also the 6, and it is inside the group, so it's horizontally moved, so it is 6 units left. And finally, we have the minus 10 outside the group, so it is affecting vertically, so it is 10 units down. We have 4 types of transformation. Now it's time to graph. How can we graph the absolute value? And then we will state the domain and the range. Everyone knows now that the parent function is the absolute value, v, and it has a vertex at 0, 0. If you use the transformation technique, then this will move 2 units to the left, so it will be somewhere here. Then 3 units up, so it will move 1, 2, 3, so finally it will be here. Keeping the same slope since there is no stretching or compression. Okay, now this will be the final destination. But sometimes it is difficult to move left or right, so that's why we will be more accurate and we will use table. How can we generate the table? The most important point is this vertex, the tip, which is the bottom, the lowest point, أقل قيمة. We need this vertex. To find this vertex, make what is inside the absolute value, make it equal to 0. So I will set the x plus 2 equals to 0. And I will solve for x. So x is negative 2. This is the most important point that I need. Because if you know this point, and you know any point to the right and any point to the left, then you can match and have the correct V shape. So this is exactly what we are going to do. We will generate the table, assuming the value of x, but you must assume the minus 2 that we found before, which is the vertex. So this is our vertex. Now, choose any point below and any point above. I will choose negative 3, which is less than minus 2, and I will choose minus 1, which is more than minus 2. Then I will replace instead of x. If you replace x equals minus 3 here, so g of minus 3 is minus 3 plus 2 plus 3, which is absolute value of minus 1 plus 3, which is 1 plus 3 without absolute value, which is 4. Repeating the procedure for minus 2 plus 2, 0, 0 plus 3, 3, and put the minus 1 here. minus 1 plus 2 is 1, and absolute value of 1, 1. 1 plus 3 is 4. And as you see, there is a symmetry somewhere here and there. And let's plot the points now. I will use the green to show you how the new graph look like. Negative 3 and 4, you will go to minus 3, and up to 4, here we go. This is the first point. Minus 2 and 3, this is minus 2 and 3, and minus 1 and 4, this is my point. And when you match, you will have exactly the graph that you have expected. We used two techniques, either the table or the transformation. Use the way you like. But remember, this is more accurate. The table is more accurate. We are going to use the table, which is better. Now let's graph another one. First, as we have agreed, أول خطوة, the vertex. To find the vertex, let's set 2x minus 2, the value, the expression inside, to be equal to 0. نخلي اللي في الداخل صفر عشان نطلع الفيرتكس أقل نقطة ممكنة. ونطلع الx. So 2x is 2. Divide both sides by 2. So x is 1. So my table will definitely include the 1. And I will choose 1 below, 1 above. Replace each value. When x is 0, exactly, I will replace this x, and I will find the result. 2 times 0, 0 minus 2 plus 1, absolute minus 2, 2, 2 plus 1 is 3. So this is 3. And if you assume x1, 2 times 1, 2, minus 2, 0, 0 plus 1, 1. If you assume 2, 2 times 2, 4, 4 minus 2, 2, absolute value of 2, 2, 2 plus 1, 3. You are now good enough to know it without bothering yourself. And now let's plot the points. 0, 3 is here, is on the y-axis, 1 and 1, and 2, 3. Now, if you match, you will have this type of function, as we expected, V-shape. But let's ask ourselves, we expected that it has been moved 2 units to the right. احنا توقعنا 2 units to the right. بس احنا شايفين انه نتحرك 1 unit only. What is the reason for that? What's the explanation? Justify. خلينا نبرر ليش. When we have explained that translation, we were explaining it when x was alone, not multiplied by anything. So I will take the 2 out as a common factor and divide each term by this 2. So when you divide the 2x by 2, it will be x. When you divide the 2 by 2, it will be 1. That means it's the same function here, but written in a factored form inside. طريقة يعني مختلفة شوي مكتوب. And we can describe now. هلأ ممكن نوصف. هنلاقي إنه في 2 inside, more than 1, so it is compressed horizontally, and that explains that it is becoming thinner, أضعف وأنحف. x minus 1 means 1 unit to the right, وفعلا هو تحرك 1 unit to the right, as we can see in the new graph. So this is like a kind of tricky question if you are describing the translation. Okay, here it's a little bit more difficult question. How can I graph it? Also, I need to know the point, which is the vertex that is assigned here, and I will set 1 over 3x plus 1 equals to 0. So 1 over 3x is minus 1. Multiply both sides by 3 to solve this equation, so x is minus 3. So my table should include the minus 3. I'll take points below and above, but I will be careful because here x is multiplied by 1 over 3. We have denominator 3, so I will use multiples of 3, either below أو above. لأنه في مقام 3 فأختار أعداد من مضاعفات الثلاثة من جدول ضرب 3. فلما أختار أصغر من 3 I will choose negative 6. ولما أختار أكبر I can choose 0 أو 3 أو 6. It's good. 3, 6, it's fine. Because I want to avoid fraction عشان أتجنب الكسور. Let's replace. When x is minus 6, this will be the replacement. I copy everything the same thing, and this is the replacement. I will replace this x minus negative 6. So this will be minus 2. 1 over 3 by minus 6 is negative 2. Negative 2 minus 2 plus 1, absolute value of minus 1. Minus 2, absolute value of minus 1, 1. Minus 2 times 1, minus 2. Minus 2 plus 4, 2. So this will give us 2. And if you replace with 0, it will give us 2 as well. Try it and you will find the same thing. If you replace with minus 3, negative 3, when x is negative 3, so minus 2, absolute value of 1 over 3 times the minus 3, plus 1, then plus 4. This goes with that. So we have minus 1 plus 1 plus 4. And this one is 0. Minus 2 by 0 is 0. 0 plus 4 is 4. So this will be 4. We should expect that this graph is reflected, flipped, انعكس. Let's see. Negative 6 and 2. 1, 2, 3, 4, 5, 6. Negative 6 and 2 up is here. This is 2. Negative 3 and 4. Somewhere here. This is 4. And 0, 2 is here. Okay. And we will match. We should expect that this shape or this figure is translated up 4 units. Yes, definitely فعلا نتحرك فوق 4. We should expect that it has reflection. Yes, it's upside down and there's kind of dilation here vertically and horizontally. But in all cases here, we didn't find the domain and the range, and now let's find the domain and the range. We agreed that the domain is always all real numbers because it can accept any value of x. The problem is in the range here. The range is all the values of y that have been used. Actually here, if you look carefully, this is the new graph. Values of y started from 3 and above. Everything is above the 3. And you can expect that from just looking here. من مجرد النظر تعرف إنه the range here is f of g of x, a small function. So our range here is g of x, or here y, more than or equal to 3. So this was outside. If there is nothing, you will say is more than or equal to 0 with no worries. Even without graphing, بدون رسم أنت تتوقع. هلا هاي بدون رسم إحنا نتوقع g of x كان اسمها yes g of x is more than or equal to 1 وما في minus فما انقلب ما في flipping, so it's more than or equal to 0 because it's opening up مفتوح للأعلى. And فعلا it's 1 and above. The value inside does not affect. اللي في الداخل ما حتتحرك ما حتأثر على الرينج لأنها it will move only right or left. Okay, let's see here. We should expect even without looking that y is, or g of x is, there is a minus here, so instead of more than, it will be less than this value 4. G of x less than or equal to 4, وفعلا all the values are less than or equal to 4. This is the story of the domain and the range. Now here, use the graph of the function to write its equation. Let's see here. How can we write the equation? Originally, y is absolute value. It has been originally at 0, 0 with slope 1, parent function. It has been moved to the left 20, so I have to write plus 20. No movement up, so nothing will be added here, nothing. Now we need to verify the slope if it is 1 or not. Let's check the slope of this line. it is rise, so we are choosing 2 points, and we will count the rise, which is in our case 2, and the run, which is in our case 20. Negative 10 to negative 20, from 0, negative 20, 20 units. So my slope here is rise over run, which is 2 over 20. If you simplify, it is 1 over 10. اختصرنا 1 على 10. So I will put it here. طيب. If somebody has chosen this part, you will tell me هذا negative راح يطلع. Don't use it, because if it is negative, that means the graph will be flipped, and it is not flipped. It is opening up. So only use the positive value. So finally, you can write it in this form, or you can write it in this way, in the decimal form. This is how we write the absolute value function from the graph. And here, finally, we have a real-life application. Certain types of glass heat and cool at a nearly constant rate when they are melted to create new glass products. We don't care about any verbal statements here. We have the graph here ready, which is easier for us. And let us represent this in terms of function. Since it is flipped upside down, I am sure that there is minus sign here. Now, there is shifting here. From the graph is shifted to the right until it reaches 9, right? So it is absolute value x minus 9 or plus 9. It should be plus 9. So it's using to the right. If it is moving to the right, so it is minus 9 because it has been moved to the right. Right. Now, what's left? We have noticed that it has been moved up until it reached 1,100 and then flipped. So this is the minus sign. Now, all what you need now to find the slope. The slope can be found using the 2 points that were mentioned here. You can either use this point with that point, which is better for calculation, this and that, and apply the slope formula. So we can choose that this is x1, y1, and the other one x2, y2. Let's apply the slope formula. 1100 minus 29 over the other one, the x is 9 minus 0. So you will subtract 1100 minus 29, which is 1071 over 9 minus 0, which is 9, and I will keep it as it is. You can divide. This will be negative 119. Finally, you will write x minus 9 because it has been moved 9 units to the right, plus 1100 because it has been moved up. And this is your function that we are looking for. Okay, that's all. Thank you for watching. Goodbye.